Yeah, the recording is started. You can write your roll numbers in the chat box. So I guess the screen is visible. Can someone respond?
Yes, sir.
Okay. So in the last lecture, due to lot of absenteeism of students, we have decided to revise the things. Now we will not wait for them. Actually, we have studied this basic embedded C programming concept, basics of embedded C programs, in the previous lectures. So today we are going to do this on chip peripherals. We are going to write a programs in a C language for peripherals such as you will be able to interface IO devices like switches and LEDs. So before we go for this point, let me take one paint so that you will understand what I mean to say here when I say uh, interfacing, right? Okay, IO devices in that LED and switches, right? So I guess you are able to say this. So if I try to draw some microcontroller or chip, then you will find such kind of package, right? So I can show you. This way the processor or controller is being represented, right? And such a controller or processor will have several pins. We call it as a general purpose input output pin. But they are not general purpose input output pins by default. We have to make it to behave as a general purpose input output. So today we are going to discuss the LED and switch interface. So before I move on, quickly let us understand what is switch and how it operates. Let us understand this switch and LED and how they are operated. Right. So if I try to draw the LED, right? So LED will look like this. LED stands for light emitting diode, right? So this type of LED will have two terminals. One is anode and second one is cathode, right? So this one you can treat it as an anode, right? So this is A. A stands for anode. This is A. K stands for cathode. So when I connect this anode to the positive terminal of battery, or let's say positive potential, and when I connect this cathode to negative terminal, what happens? What happens? Can anyone tell? When I connect A to the positive terminal and K to the negative terminal of battery, what happens? What will happen? This will turn. It will light up. When it is connected to positive, it is connected to negative. This LED bulb, LED will light up. So we if we reverse the polarity, or if we keep those two terminals floating, what will happen? LED will be uh, it will not glow, in fact, right? So when we connect anode to the positive, cathode to the negative, LED will turn on. Second thing, on the other hand, you can have a switch, right? So this way the switch can be represented, right? So in a current path, or you can say in a circuit, when we have such kind of arrangement, and when I press this switch, what will happen? That connection between this terminal, let us say terminal A, or let's say terminal P to terminal Q, will get established. When I press this switch, whatever status of P is there, it will be copied to Q. So as simple as that. So if I press the switch here, status of P will be copied on Q. Whatever current, whatever voltage is present at P, it will be copied to Q. So as simple as that. Now can someone tell me, now someone tell me, if I want to use this LED, where should I connect it? On the output side or input side? Whether it is input device or output device? This is my basic question. LED is a input device or output device?
Output.
Yes, it is a output device. So it should be connected to output pin of microcontroller. Or you can say you can connect it to output pin of Cortex M3 now. Right, so this way you can connect LED. Here you can have this terminal connected to ground. Right, so this is ground, this is LED. This way you can connect the LED. But on the this side, on this hand, how you can connect it? How you can have a switch? The best way is to connect it across the ground. Right, so what we have done here is we have two devices. One is LED, one is LED, and second one is switch. LED can behave as an output device, switch can behave as an input device. So we will use those two devices, two components, with microcontroller, or let's say Cortex M3 for this case. And here I would like to say the device which we have used here is LPC1768. We can use this device LPC1768, which is Cortex M3 processor. This is your Cortex M3 processor. Right, so now basic things we should be able to we are going to perform two tasks here. See, first thing, we have connected this LED to, let's say, some pin, let's say GPIO2. Let's say it is connected to GPIO, or you can say, yes, port. You can use port, right? So let's assume in the first case we have connected this LED to port 2. Now I want to blink that LED. So for blinking, how you can write a program? Now I am taking you to some other sheet. So for that, I hope you understood. If I make this port 2 pin high for a movement and low for a movement, the transition between high and low is observed on LED, and because of which it is called as a output device, right? So let us go to some programming. Yeah. So here I should write LED blinking. LED blinking. Right. Now, what things we are going to use? We are going to use port. Which port we are going to use? Port 2. So port pins are required to be configured as a GPIO. So how will you configure that port 2 pins to be behave as a GPIO? Are configured as GPIO using, we have one control register using pin select. This is a register of, keep it in mind, this port 2 is one of the port of Cortex M3, and it can be configured as a general purpose input output by writing something to pin select. And let me tell you what is this something. If you write this as 0000, then it will be configured as a general purpose input output, right? So this is first. Second thing, then second part of that is we have to configure that port 2 as output port. So port 2 pins are configured as output port using, now another SFR I'm telling you here, FIODIR, file input output direction. This is what meaning of this is, right? So if you write something into the FIODIR, the pin or the port will be configured as output or input port. I'll tell you what to write in a FIODIR so that the port 2 will behave as the output port, right? So this is another aspect. Then LED are this LED will be turned on by sending high pulse on that FIO SET. So this LED will turn on by sending high pulse on which register? FIO SET. So file input output set register. This is the meaning of that. So I have told you three SFRs as of now. Then one more SFR we required to use, right? So another SFR is after some time the LED are turned off by sending a low pulse using FIO-CLR. So low pulse, where you will send it? This LED will turn off by sending a low pulse on which register? FIO-CLR. Right. So how many SFRs we have seen just now? Pin select. So with this pin select, what will happen? Pin select will configure port 2 as general purpose input output. Then we have FIO DIR. With that, you can configure your port as an input or output port, right? For this case, we want to configure it as an output port. Then we have FIO set. This will turn on the LED. FIO clear, CLR. This will turn off the LED, right? So now I'm writing main program, actual program, right? So these are the couple of things that you should know. Now I am writing actual program. So first instruction that we must start with, can someone respond in C language? How you can start your program? What would be the first instruction in C? It should be include, right? So what do you mean by include? This include will add all the libraries corresponds to what I am writing here in this bracket, right? So LPC 17xx .h, all the header files will be added into this program, right? So all the libraries corresponds to this device are added with this instruction. Is it clear? First instruction. The next and most important is we have to call the delay, right? So you may have the library for delay, or if you don't have the library for delay, you write your own delay subroutine, right? So I am writing here delay program. This is a segment of program which would, if it is called, it would generate the delay that has been defined in that loop. So for that, void delay underscore millisecond ms. I'm going to define some unsigned integer. Is it visible to everyone? Check the visibility. Yeah. Void delay. Hello. Is it visible? Can someone respond? Is it visible? जागे आहेत का सगळे झोपले?
Yes, sir. Yes, sir.
Okay. So first instruction here, we are using it for generation of delay. Here we are defining this unsigned integer. Unsigned integer called as ms. Right. After that, we will write up this opening curly bracket. Here I am defining this unsigned integer I comma j semicolon, right? So I have defined here two integers. This has to be in a lowercase. The next, we are going to write a for loop, and we know that how the for loop behaves. This for loop will have couple of things inside this structure of for loop. Can anyone tell? For loop, it will have initialization, so it is initialized to first value. Then it will have a condition, right? So when I is less than a millisecond, then we have an expression I plus plus. Right, so what will happen after doing this? This loop will continuously increment. First of all, the value of I, it will become 0, and its value will be checked against 1 millisecond. If its value is less than 1 millisecond, then it will increment the count in I. Right, so plus plus. So this way you can generate a delay. So for more delay, you can have another integer, unsigned integer, right? So this unsigned integer, here I will use for inside for, right? Means what? I'm using another integer j. So initialization value would be 0, comma. I will check whether j is less than 20, or that one is sufficient. One loop, one delay is sufficient. So this way you can generate the uh, delay. Right. So this is a program to generate a delay. Now we are writing a main program. So how will you write a comment? For that you can write a backslash star. This becomes a start of comment block. So start of main program. So here onwards your main program would start, and how will you close this comment? Star and backslash. Right. So here I'm going to start the main program. Here I will use int main. Right. Opening curly bracket that indicates start of the program. So here what I will write is system S capital init. So after doing this, what will happen? System in it. So this will start. What you can say is comment. Comment can be highlighted by double slash. So this will configure clock. Configure the clock. The next instruction in it is now we have to configure the given port to as GPIO. So if I want to configure it as a GPIO, त्याला कॉन्फिगर करायचं असेल GPIO, तर आपल्याला ह्या पिन सिलेक्ट मध्ये 00 लिहावं लागेल, राईट. So we have to make it 00. Pin select have to be made 00. So LPC underscore pin control. You have to keep this syntax in your mind. So pin control मध्ये जी पिन सिलेक्ट आहे ती पिन सिलेक्ट 4 त्यातली मी सिलेक्ट करतो. म्हणजे that means pin number 4 I am targeting, right? So pin select 4, this one I have targeted, and it is equal to 0 cross 0 0 0 0 0 0. So this way you can configure that pin number 4, pin select 4, to be configured as general purpose input output. So this way GPIO configured. This way you have configured GPIO, right? Next, I have to make that GPIO to behave as an output. So to behave as output, how you can do it? FIO dir, direction register is to be written. सो आउटपुट म्हणून केव्हा कॉन्फिगर होईल? ज्यावेळी आपण त्याच्यातले सगळे बिट्स FF करेल. इनपुट करायचं असेल तर 00 करायचं आहे. थोडंसं उलट आहे ह्याच्या 8051 पेक्षा. So you should be able to keep it in mind. LPC underscore GPIO. Now I'm configuring this GPIO. Which register I said? FIODIR. Right? So this is equal to 0 cross FF, 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 FF. Right? So this way, what will happen? What will happen? Port 2 configured as output. Port 2 is configured as output. Now here you can write a loop. So you know that how we can write a loop? While. You can use a while loop. Right? So when I write in inside that one, that means it will be executed infinitely. Right? So here the while loop starts, the while loop begins here. So you can write here opening curly bracket, and you can start writing while loop. In a while loop, you are making that port pin high and port pin low. So how you can make it? त्या पोर्ट पिनला हाय करताना तुम्ही हा सेट करायचा आहे, FIO सेट करायचा आहे, आणि त्या पोर्ट पिनला लो करताना FIO क्लिअर करायचा आहे. ठीक आहे. सो हाऊ विल यू डू इट? LPC underscore GPIO LPC underscore GPIO2. In that, which register I want to set? FIOSET, right? So this register you are going to configure as FF, 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 FF. What will happen after doing this? It will make all port 2 pins high. What will happen after doing this? It will make all the port pins high. ठीक आहे. त्यानंतर आपल्याला परत एकदा डिले, या ठिकाणी डिले कॉल करू शकता तुम्ही. डिले, how much delay is sufficient? How much delay is sufficient? 100 millisecond. Yes, it is sufficient. 100 millisecond delay is called, right? Otherwise you will not be able to identify the transition. And again, similar instructions I can use. Instead of that, I will copy GPIO2 is FIOCLR. This register I will make it as 00000000. This will make all the port 2 pins low. Again, call a delay of 100 millisecond. You can write a closing curly bracket. And again, closing curly bracket. So this is final program. This is the program to blink Cortex M3. This is a program to blink the LED which is connected on Cortex M3. Is it clear? Any doubt in this? This syntax, etc. is very simple. It is very similar to that C language program. Only the thing is you should be able to configure the registers, right? So in the examination you will not find any of the program. मागे जेवढ्या एक्झाम झालेत त्यातल्या कुठल्याच एक्झामला प्रोग्राम विचारला नाहीये. सो यू आर ऑन अ सेफ साइड की तुम्हाला कॉर्टेक्स M3 पूर्ण स्टडी करावा नाही लागणार. त्याचे इंटरनल स्ट्रक्चर, त्याचे इंटरनल रजिस्टर, जसे मी आता हे 4 रजिस्टर्स तुम्हाला दाखवले इथं. पिन सिलेक्ट, FIO, DIR, then FIOs, this set and FIO clear. So you don't have to study all those registers. पण एखाद्या वेळेस ब्लिंकिंग वगैरे असे प्रोग्राम विचारू शकतात. सो यू शुड बी एबल टू राईट सच programs, right? So with that, your LED which is connected to this port 2, this LED will start blinking. ठीक आहे. आता आपल्याला एक थोडस याला कॉम्प्लेक्स लेवलला न्यायचं म्हटलं तर हा LED जेव्हा मी ते बटन प्रेस करेल तेव्हाच ग्लो झाला पाहिजे. समजतंय का? रॅन्डमली त्यांनी ब्लिंकिंग होण्यापेक्षा मी ज्यावेळी तो LED प्रेस करेल त्याच वेळेला, फक्त आणि फक्त त्याच वेळेला तो ग्लो झाला पाहिजे. Right? So how we can do it? So I will modify the program now. समजतंय टास्क काय आपल्याकडे? ज्यावेळी आपण हे स्विच प्रेस करेल त्याच वेळी फक्त LED ग्लो झाला पाहिजे. स्विच ज्यावेळी आपण रिलीज करू त्यावेळी तो LED ऑफ झाला पाहिजे. ज्यावेळी बटन दाबेल त्याच वेळी LED ऑन, ज्यावेळी आपण बटन रिलीज करू त्यावेळी ते LED ऑफ झाला पाहिजे. मग त्यासाठी आपल्याला प्रोग्राम कसा लिहिता येईल? आय विल गिव्ह अनदर हेडिंग. Program for switch and LED. So program for switch and LED. I hope it is visible, right? So this is a program for switch and LED. Now here we are going to add the libraries. First of all, we will add the libraries. So include what you want to add: LPC 1768, LPC 17. If you want to specify the name, you can, otherwise XX. Header files related with that device will be added. Then you can define switch pins, means like in Arduino how you define the switch pins. So I can use the same way, define switch pin. I have to write this S as capital. This is the syntax. Switch pin, and pin number 11 I'm going to use for switch. Then I can define the LED. So for that, define LED pin. See the syntax how I am writing this switch pin. S is capital, P is capital. Here I am defining LED pin. So L is capital, P is capital. So let us use pin number 0 for LED. Right. So if I press the switch which is connected on pin number 11, the LED which is connected to pin number 0, it will be turned on, or it will be glowing. It will start glowing, right? So this is the main program. This is how I can start a main program. So main program. Here I can write the comment blocks. Right. So here we can write the main program. For that, I should define unsigned integer. Let's say 32-bit. 32-bit switch status. switch status. Then I should write your system integer, right? So this will start the clock. It will configure the clock. So system init. Right. So this will start the clock. Next is you have to select those two SFRs, right? Right. So LPC. After that, you must say pin control register, and pin control. I told you which are those pin control registers. Pin select that second bit. Make it 0 cross 0 0 0 0 0 0. Yeah. So after doing this, what will happen? This pin select, it will behave as a GPIO, right? So the port 2, it will behave as a GPIO. Next is you have to define it as input or output. So LPC GPIO2, this you can configure by writing FIODIR, right? Meaning of that, file input output direction registers. So what you have to do here is you have to make it uh, direction, actually, that direction. So you have two defined names, defined labels. So one should behave as a input, one should behave as a output. आपण पोर्ट 2 वरचे दोन पिन्स डिफाईन केलेले आहेत. जी पोर्ट 2 असणार आहे त्या कॉर्टेक्स M3 ची, त्याची पिन 0 आपण एलईडी म्हणून वापरतोय, आणि पिन 11 जी आहे ती स्विच पिन म्हणून वापरतोय. ठीक आहे. सो दॅट वे यू शुड डिफाईन इट हिअर. म्हणजेच हाऊ विल यू डिफाईन इट? So here you can write 1 greater than LED pin just a minute, and 0 less than switch pin. Keep this syntax in your mind so that switch pin. So this way you can decide the LED pin. LED pin means it will behave as a output pin, and switch pin, it will behave as a input pin, right? So LED will behave as output, switch will behave as a input. Now you can write a complete loop, because everything have to be executed in a loop. आपण एकदा बटन दाबलं, रिलीज केलं की एलईडी ऑफ झाला पाहिजे, पण हे जेव्हा केव्हा आपण एलईडी स्विच प्रेस करू त्यावेळी सेम थिंग शुड हॅपन. सो while loop, that opening curly bracket, here I can write switch status. Switch status status, you should read the status of switch. How you can read the status of switch? So you need to get it from LPC GPIO to FIO. Here I should use the pin. How will you get FIO pin? And that has to be taken from or simply you can mention, because you have defined it, switch pin. So automatically it will go to your pin number 11 and it will copy the status, right? Now you have to use if else, right? So if, you can write the condition here, if switch status, if switch status is equal to 0 1, in that case what is to be performed is to be returned here. So what should happen if switch status is high? Then in that case LPC21 LPC GPIO FIO pin, or simply you can write uh, this because we have defined this one LED pin, right? So LED LED pin should become equal to 1, right? If switch status is high. You can close this and you can write else. If else loop I am using, right? So else, if this condition is not true, then this condition is true and this action is to be performed. So what is that? This LED pin should go low. Here your else loop is completed. Here your if, sorry, while loop is completed, and here your main program is completed. So this way you can write a complete loop. It will continuously check the status of switch. If its status is 1, then LED pin will go high, that becomes 1. If its status is low, LED pin will be low, right? So with that what happens is, when you press the switch on that circuit, the LED corresponds to that switch will be turned on. So if you release the switch, your LED will be turned off. So I have written two programs here. One is to blink the LED. This one is to blink the LED, and this one is for program for switch and LED interfacing. Right. So I have written two programs. I will drop these two programs on a WhatsApp group so that you will be able to practice. You will be able to read it carefully. Right. So this is program 1, and this is program 2. Right, so I give you 10 minutes are there, so you can utilize this 10 minutes time to read it. So I will drop this file to your WhatsApp group. Use remaining 10 minutes of this lecture in reading that program. Right, so I will drop it on your WhatsApp group. So if you have any doubt, you can ask. If you have any doubt, you can ask. Otherwise, you are allowed to leave the meeting. I will drop this program file on your WhatsApp group. Yes, I have sent you the program files, so you are allowed to leave the meeting. You just practice the programs which I have shared. You are allowed to leave this meeting. You can leave the meeting.